Hello, welcome to the Thursday night stream. We already got folks in the chat, which is great. Glad to see people hanging out here doing some networking on a Thursday night, at least Thursday night for me in this time zone. We are going to do some QoS. So we got looks like, although I'm starting to doubt things, but day 387 in this journey. Hola, Dirk. Good to see you. Yeah, it looks like we are going to hit a QoS single rate 3 policer. And this comes out of sort of looking at the blueprint and policing coming like pretty early on. So I'm skipping around a little bit in the INE workbook, that is. And by the way, the lab I'm about to do, standard disclaimer, this is not my lab. This is one that I'm going to work on stream, but the workbook I do not show, the INE workbook. There's a link below if you'd like to purchase it. It has the answer key, screenshots, it has explanations, lessons. So you definitely want to check that out if you want to do these labs yourself. It's a very simple topology. Also, there's a link down below. We're just going to be working with 2 routers, I think, tonight. Router 1 and 4 that share a segment. And mainly we're going to be working on router 4. So yeah, I reviewed some material today. I reviewed this in networklessons.com. This is the same material I reviewed for the written exam, and it's good. It's very good material, but hey, Site of Origin, thank you for that resub. 7-month streak. Site of Origin. 7 months in a row, still following your journey to your IE. Thank you so much, my friend. You are a beast. Amazing. Thank you for that support as always, Site of Origin. I appreciate it, and nice streak there, man. That is awesome. Good bits, yes. Hey, I'm gonna need them tonight, Site of Origin. I need them because I feel very shaky. It's like when you you know, if you step out on the ice of a frozen pond, you think it's going to hold you, but you're kind of taking a gamble. That's where I'm at tonight. So we'll see how far we get. The classification and marking. Now that went reasonably well. By the way, let me know, guys, if that music is a little too loud. Let's see here. It might be. I'm going to turn it down a little bit. So yeah, we're on thin ice, but we're going to see how it goes. I reviewed the lesson today on policing and started actually looking at it yesterday. And of course, you know, there's this concept, and I'm not going to explain this very well. Probably one of the best videos out there that's free is one from Kevin Wallace. Let me see if I can find it real quick. It is in my it's in my agendas, which are on GitHub. So I have linked this before. As a matter of fact, that's probably the fastest way to find it. Let me do a search real quick using actually VS Code, of course. And let's open folder. Let's just do here streaming agendas. I'm already there. Save all. This will be QoS. And let's find did I click it correctly? Find. Probably in the wrong screen here. Stream agendas. Finding files. Okay, that's right. It's a little different on the Mac and PC. Not much. Let's just do that. Okay. 3 results in one file. Okay, let's go back to... This is going to be earlier days, of course. January, yeah. Okay, this is going back 22 results in 10 files. Maybe I did not. January 1st. Yeah, okay. I will Google search it. Okay. I think this might be it here. I've never really gone through this may be it. I'm not sure. He has a free video out there. I'll find it and post it Discord. But it was really good, really helpful for understanding QoS and policing and shaping. So anyway, let's get into it, folks. Oh, did you find it, Casadix? Let's see here.
Hey everybody, this is Kevin.
Yes. This, it's funny because it says CCNA, but I actually found it useful to help me with the written exam. Thank you, Casadix, man. You are on point. I'm going to put this in the agenda for today, in the meat chunks, so I have that as a reference too. Oh no, I didn't want to do that. Yeah, good job, man. Awesome. Here we go. Really good video. It really helped it to click. Some of it to click for me. I probably need to review it. It's been a while, and it's one of those things that if you don't ever do it that often, and you just visit it once in a while, you have to reorient again. At least that's been my experience. So what the requirements of this lab are, we're going to use R4 to meter incoming HTTP traffic. So we're going to act like the cop here on router 4, the officer. We're going to act like the ISP, right? And the rate is going to be less than 128K. Anyway, we're going to have, right, so you have different methods of policing, and tonight is a single rate 3-color. And what the colors mean, of course, is that you have, well, rates are, you either have a CIR, just a CIR, committed information rate, which would be single rate, or you have a dual rate, which is a committed information rate and a PIR, like a burst rate. So we're going to do, as I understand in this lab, a single rate 3-color, which will have 2 token buckets. So the colors refer to policy thresholds, in a sense. So generally, your first threshold is going to be your conform color. And in this case, if your rate is less than 128K, that's fine. We're going to mark it with an IP precedence of 1 and forward it, right? If it exceeds 128 kilobits per second, then we will, exceeding is another color. And generally there's going to be an action associated with that, right? In this case, forward and mark. In this case, we will forward and mark with a lower class of service value or IP precedence value, right? One of my cards, my Anki card, flashcards, is to name like all the IP precedence values by name. And I can just about get them. I think 0 is routine, 1 is priority, 3 is immediate, and I don't really get all these. We go from routine to priority to immediate, and then we have flash override. There's one more critical. Then we have internet network control and network control as the. So we're just gonna say, hey, this is exceeding. It's basically a lower priority. We're gonna give it a precedence of 0 because downstream we may do something different with it, right? Then we have our third color, which is the violate. And these will all factor into our policing command. We're building up to a policing command here, right, on the interface. In this case, we're going to drop. The action is to drop. This part is throwing me off because it talks about a burst size. But we are doing... single rate. So this part is confusing me. So what I may do is at least do this part and then just see what the workbook has to say about this. I'm going off of some information from Network Lessons as well as I go through this. So let's set it up here. Yeah, PIR is peak information rate. So that would be a dual rate, though, policer. And yet this lab says, according to the title, it is single rate, 3-color policer. So I don't know why it's bringing in the burst size. We'll find out. Okay, so let's look at a sort of sample configuration here. I'm not showing this on screen, this is Network Lessons, but it's going to help me build my statement. So we're going to say on router 4, and these are booted up, so let's fire up the consoles. Oh yeah, that's right. How am I logged in here? I'm logged in native, it looks like. Okay, let's log back in. Oh, I think I know. I think I may know what's happening here. Let's see. 128.0.0.0.128.0.0. Okay. So we've got router 4 is going to be, essentially it's going to be against Jazz 0.1.1.46. So what we're going to do is we're going to say, yeah, we're going to do a... Now this has, the example I'm looking at in Network Lessons is just matching ICMP traffic, but I think we want to do all traffic. Do I have to create a class for that? Let's see, class map, all traffic. Match any. And then policy map. I may be going beyond what I need to do here. Single rate 3 color, class all traffic, and then we're going to say this is what we're going to do with it, right? So police um 128.0.0.0, and I think this is where, yeah, okay, this is what Colonel's talking about. So burst bytes. So I could hit enter here. But it's saying burst bytes, so there's a formula that I kind of skipped over. So we have the burst size is large enough for a burst of 200 milliseconds and 300 milliseconds. This is the thing that can be confusing, I know, is that the burst is in bytes. So even though our rate is in kilobits per second, so we have a the rate is amount plus time, so 128 kilobits per second. We want the burst size to be large enough for burst of 200 milliseconds and 300 milliseconds. So that would essentially say 300 milliseconds is what I'm thinking. Oh, for burst 200 milliseconds and 300. So that's a range of 100 milliseconds, which is 0.1 seconds, right? So that's 100 milliseconds. Yeah, I'm not going to do well with this. And I know it's probably premature coming into this lab, but there's a formula here. Let me back up to it and see if I can figure this out here. Okay, this is single rate 3 color. That's right. You have your BC bucket, your BE bucket. Yeah, above you see that the BC bucket gets the spillage. All right, so the way this works, when the number of bytes is less than or equal to the number of tokens in the BC bucket, right, is conforming. Packet is not conforming and is less than or equal to the number of tokens in the BE bucket. Police will remove the required tokens from the BE and perform the corresponding action. If the packet is not conforming or exceeding, it is violating. Okay, I'm trying to figure out how to calculate the BE. You're saying 0, 128.0.0.0.0. So what if I put 0 here? Burst bytes. It has to be between 1,000. Okay. So basically we have 128 kilobits per second. We want to allow a burst size large enough for 0.1 seconds. So basically divide this by 10, right? So we have 128 this many bits per second. We want a burst size large enough for burst 200 milliseconds and 300 milliseconds. So that is between 2 and 300. Is the way I'm reading that. To me, that's almost like it's 100 milliseconds. Well, that can read either way. Let me look back at the... Should the burst size large enough to accommodate normal and excess burst durations? Of 200 milliseconds and 300 milliseconds. Why do they have two figures here? This is one of these... the sneaky meter is lifting a little bit here. Sure, the burst size is large enough to accommodate normal and excess burst durations. You know what? I'm going to go with the 300 milliseconds. So what that tells me is 0.3 of a second of burst data. So it's basically 128,000 times 0.3. $384 bytes. This is bits. $375 bytes. Oh, that's not even large enough, so that cannot be right. Oh, so you're also thinking, Colonel Panic, the 300 milliseconds, right? That's what I'm thinking too. I'm just doing my math wrong here. So a tenth of 128,000 bits. Oh no, that's kilobits, right? 128 kilobits per second. That means this many bits per second. So we divide that by 10. Or no, 1,000, right? Because this is, no, bits per second. Bits per second, that's right. See, yeah, I'm trying to compare milliseconds to seconds, but we want 300 milliseconds is 0.3 of a second, right? Or we could do 1/10 of this by 3. I think that's what you're doing. So a tenth of that would be 12800, right? Bits. I should put BPS, yeah. So 12800 times 3 is 38,400 bits per second. That's right, isn't it? 128 kilobits per second is 128,000 bits per second. A tenth of that is... Oh no, you're right. 12,800 bits per second times 3. Well, let me run through this again. 128 kilobits per second. This is a small, this would be like an old, what is this, like an ISDN circuit? This is a small circuit by today's standards. Really small. I hope you're not paying much for that. Remember, the old modems were 56, like maximum. The dial-up was 56 kilobits per second, right? So this is like a, yeah, this is... All right, so anyway, 128 kilobits per second is 128,000 bits per second. You take off 1 0 because we want to deal in... We need this figure... tell you what, this makes a little more sense to me. Times 0.3, right? T1s and ISDNs are super expensive now. I bet they are, because not only do you have to get a regular, they probably give you a regular Ethernet, and then they have to provision T1 encoding or ISDN on top of that, right? So yeah, so if we want 300 milliseconds, that's 0.3 seconds. So if we get this many in 1 second, we want 3/10 of that, right? Times 0.3 equals bits or 300 milliseconds. So let's do that. 128,000 times 0.3, 384,000 bits. There's 1,024 bits in a byte, right? So we take divided by 1,024 equals our burst rate in bytes. $375 bytes. Caseta says 200 milliseconds equals 200 times 10 e minus 3 equals 0.2 seconds. That's correct. But the lowest value we can put here is 1,000 bytes. Let me see. Let me look at the example here. Yeah, I'm sure I'm not doing something right. Now there is a formula here. Let's see if we can fit it into this. Yes, you got 38,400. But remember, which is true, that's bits, right? Casadix? That is bits. But the value we have to put here is bytes. So that's why you divide. Hold on, you've got 38400. Yeah. I really studied that hard because I figured that would probably be like an exam question. So let's take a look at the, well, let's just put it at 1,000 for now, and then we'll find out where we're wrong. Either that or it could be a platform issue. Like maybe they don't allow the value that's in the original lab because we're dealing with such a small 8 bits. Why am I saying 1024? 8 bits in a byte. I don't know what I was thinking, man. I do not know what I was thinking. That's like, yeah, divided by 8. Thank you. 384,123 divided by 8. 48,000. Okay, there we go. Thank you, Casadix. She put me on the right track. So this will be 48,123. Although it's saying 2 figures here. How many of these figures am I allowed? So what if this was 200 milliseconds? All right, let's try that one on for size. So what if we did it times 0.2? And And this is purely guessing here, but the workbook's going to tell me if I'm right or wrong. So let's do this again. 128, 123 times 0.2 divided by 8. Okay, so that puts us between 32,000 and 48,000. Okay. Conform action is set, precedence, and transmit. That will be, what was it, 1? Yeah. Wow, we put this all on one line here. Exceed action. Did I get that wrong? For 128,000 times 0.3 equals 38,400. Sure about that? Let's see. 128, 123 times 0.3. I think you're missing a 0 there, bud. Divided by 8. Wait a second. This number should be smaller. Times. It won't let me do a 0.3 on this calculator. Problems, calculator problems. This is in, yeah, I want to switch to basic. All right, that lets me do a 0.3. You're right. My calculator, okay. So this will equals 400. Bits equals 4,800 bytes. You're correct, sir. So times 2. I did not even notice that, you know, I was just hitting. See, I'll work the calculator without actually looking at the calculator, kind of like you touch type. And that's what I did there. So times 0.2 divided by 8, 3,200. That's more like it. Okay. Bear with me, folks. We will get this. Police. CIR 128, 123. Burst bytes is 3200. Okay, conform, set, press, transmit, and 1, exceed action, set, precedence, transmit, 0, violate, action, drop. I wouldn't have got this far without you folks. Conform, action, transmit. Yeah, transmit. Well, I'm not even sure if this is right, but we will find out. So, all right. Well, the cool thing is we will be able to emulate this traffic here. All right, so I need to remember, though, the takeaway is I'm going to put it here in the stream agenda. For calculating, this is called BE bucket amount. It's the CIR times yeah, this is interesting because what this does, this draws a line. So we're saying 128,000 is a CIR. We're going to take a portion of that. We're going to calculate a percentage of that, essentially, or an amount, that it's okay if we go above that. We can't exceed. And we're going to put, at each cycle, we're going to put in the BE bucket this many bytes. And if it goes over that amount, so let's say, yeah, CIR and then BE bucket is basically a percent of the CIR to conform, another percent of CIR to, oh no, another percent of CIR to exceed, and another percent of CIR to violate. Okay, I think I got it. Percent is calculated as a time value fractions of a second, right? Show, how's it going, man? Doing some policing here. Enter police song. No, I can't do that. I would get copyright strikes. You gonna give me those notes? Yeah, man, you know it. I don't know how good they are. I muddled through it with the help of the chat. I've got some more experienced folks here in the chat. I've got a colonel who is just, I tell you, Colonel Panic could barely contain himself, knowing that, because apparently Colonel Panic loves some a QoS, so I'm having some good help here in the chat. And Casadix as well, helping with the maths. Maths can be hard. It's your favorite subject. That's Colonel Panic. That is good to know. Colonel Panic, are you in our Discord? Because, well, it's your favorite at least. Oh man, I gotta play some catch up somehow. Actually, I jumped around show. I don't know if this was a case for you, but I got to the workbook, and I talked about this yesterday a little bit, that I've got discontinuity here. So I was looking at network lessons to kind of review some of the material, and then I was looking at the workbook, and I was looking at the blueprint, comparing all three. And the order in which topics are listed is just, none of them line up at all. So I went in the order of the blueprint, and the blueprint starts with classification and marking, and then it goes to policing, which is down here. I'm like, well, that's just what I'm gonna... No, I didn't know there was Discord. I'm a new viewer, thanks to DM Fiegel. Oh man, DM Fiegel's awesome. This is our Discord channel. Dimitri does comment from time to time also in our Discord, and he does post when he's going to stream in our Discord. So yeah, definitely check it out. And you may regret it because we may pick your brain on some QoS. Show and I are both trying to get on the subject. So anyway, that's why I skipped around show. I'm on policing. It kind of jumped over to that, for better or worse. And I think we've got this one figured out with the help of the chat. We're going to do It was throwing, the lab was throwing two numbers at me. It was saying large enough for bursts of 200 milliseconds to 300 milliseconds. And that wasn't hitting my mind until just now. That basically what that's doing is that's drawing a line between your exceed and violate. So a 200 millisecond burst in the time of 200 milliseconds, we want to allow and 300 milliseconds. But what that's implying is after 300 milliseconds, we don't want to allow a burst of that long. That's traffic we're going to drop. So we take 128 kilobits per second, a committed information rate, and that's per second. So we say, okay, fine, we can do a burst of 200 milliseconds. So that's 128 bits per second times 0.2. And that is wrong. 2 rolls in a bucket. Yeah, so we've got, well, yeah, so this is a 2-bucket policer, right? We've got BC and BE. And the BE bucket is, will allow up to 300 milliseconds. So 128,000 times 0.2. Yeah, this was 25,600 bits. And this is really our exceed, right? And this is our violate. This just goes out the BE bucket, it spills out on the ground. So this would be, what do we come up with on this one? Show, do show policy map. 3,200 and then 4,800. Yeah, that's right. I do have some very low volume music on. How's it sounding? Is it too low? Is it just obnoxious? I can never tell. Oh, very low? Okay, not. It's kind of hard for me to tell these meters here. Like my mic aux 2. Yeah, let me know. So the violate is 4,800. Thanks, show. Appreciate it. Feedback, my friend. All right, so we've got this set. And you know what I like is when you configure it, it's all one long line, right? Show, run, do show, run, I exceed. It's like, okay, but when you do show policy map, I like this output. It's a little more organized. I'm not sure if I had to do the class all traffic, but I'm going off an example here in network lessons. So, you know, I don't like to do the reveal on the INE workbook. I don't like to do that reveal until I'm, at least think I'm somewhat close. So I use network lessons examples to kind of give me a hint. All right, I think that is configured. I think we're good. How do we validate? This is definitely one of those things too where you can read about it all day long and it not make any sense until you actually lab it. And it's like, all right, so by the way, I want to check, there are some tools here in the Pro edition of Eve, even G. What does this rate do? I think what this does actually is it introduces, it simulates traffic transmitted at this rate. That's just what this feature is for. Let's check the cookbook real quick. All right, eveng.net. No, that's not it. Here we go. So they have a cookbook. It's actually right here, version 1.8. By the way, great. I gotta give a shout out to eveng devs. And I don't like when I thought I had this turned off, that Chrome would just download. That is one of the most annoying features of Chrome. Anyway, shout out to them because on LinkedIn, well, they actually watched my video and they said that in the future, well, they appreciated the feedback. Or some feedback I gave is if I actually come in here and I look at the cookbook to see what what they're doing, and I shout a call out. Can they add like revisions, a revision history? So they said they're going to do that going forward, which is awesome. I appreciate it. All right, let's look at quality. Edit connection link 9.1.6. Oops, I had it. .6. Let me just see what this does exactly. Right-click connection, choose this function apply on live connection, delay, packet loss, and rate. It is recommended to apply value divided by 2 on both link to achieve precise connection quality. Okay. Okay, interesting. Well, let's see. Because I don't know if I can exceed this rate unless I do, like, introduce another tool in here. Although 128, that's not too big. Let's see what we can do on our own. So let's say router 1. Yeah, we can send some big pings, right? And then we'll try the editing the quality on the interface. But let's make sure the interface is up. It is ping 151.146.4. Okay. I found a cool, I did not know this. It may have been on stream, it may not have been, it may have been in labbing in the morning. How you can ping with a DSCP. This is cool. I like this. As a matter of fact, if we want to, well, we want to see this bit change, right? So actually what we'll do, let's do this. Let's ping router 5 through 4. And then we'll see if the marking changes. Because if it conforms, we want to set the IP precedent to 1. So ping is going to be IP precedence of 0. And when it hits the interface, it should be 0 and should change to 1. Let's verify that first. And the way we'll do that is we'll just do a good old-fashioned PCAP. We'll do it on router 5, yeah. So take it a minute. I think the router might still be... Yeah, so we'll just send some normal traffic, see it come in with IP precedence 0. And, oh, I have not applied it to the interface. Hello. Hold, you know. Hold your horses here. We're not doing anything until we apply it to an interface. If you can hire all the police you want and just put them in the donut shop, they're not going to arrest anybody unless you put them out on the street, right? And put them on patrol. So yep, so all we have to do here, interface GI0 1146 and service policy. I could say she like that. What do we call this thing? Thingamabob. Oh, we called it, yeah. Input. Policy map name, single, rate, 3, color. Okay, now it's applied. Router 5 should be up. Let's just close down. I don't want any funky business between router 1 and 5, so we're going to shut down this interface. And let's just see what I'm actually going to ping the interface that's facing router 4, so 145.5. Set interface up. It is on that side. Okay, good. Probably doesn't have a route to it in this lab. And it does not. Now it should. Well, I don't know if it'll be able to route back. Yeah, okay. So now we should see in our capture, if capture is working. It doesn't appear to be. Go do this again. Why is that a weird color? That is odd. I'm gonna log out, log back in. All right, let's see what we got. Usually it takes, I've noticed for some reason, I don't know why, since the upgrade maybe, or maybe it was before that, but we want router 5. Well, we want both. Usually you have to do the capture twice. Not sure why. Not a big deal. All right, so we should, let's do another ping. And what we should see here, did it stop? Hey, new follow. Thank you, Black Wolf MX. Appreciate the follow. Welcome to the Land Tamer stream, where we talk about networking goodness. We only care about the good bits, and we discard the malformed bits. Hope you enjoy it. We talk a little cloud stuff too sometimes. Yeah, that is strange. I'm not sure why it's doing that. I need to set up my bot to occasionally just show the these links for people who are new to the stream. Oh, come on now. Guacamole. Come on, guacamole. This is not what I need you to do right now. I might have to wipe the router one more time. There you go. All right. Let's do the ping again. And we got our echo request. All right. So we should see an IP precedence of 1. And we do, CS1. Yay, it's working. We can also verify this here. Show service, is it show service policy? No, I have to show policy map. No, let's see, so interface. There we go. So we've had 21 packets that conformed. Wow, you know what's cool here I like is that it has the BC and BE. It actually labels these BC and BE in the output. That is nice. That's enough chat for me. I'm heading to start my studies. I might need to have a one-on-one with you on how to do math calculations. I still don't get it. I'll do my best, man. Sure thing, show. We should do another one-on-one, maybe this weekend, man, if you're available. Just to check in, and because I know we're covering some of the same topics. Have a great rest of your evening, show, and productive studies, buddy. You got that date counting down, so talk to you later, my friend. All right, so what I want to see now is I want to create some April 2nd. Everybody, you know, from time to time in Discord, send our friend Show there some encouragement. He's got a date coming up, an important date, April 2nd. So, and it's after April Fools, so that's a good thing. April 2nd. All right, let's see if we can. Let's send some big pings. Extended data. Oh, that's not what I meant. Size. Datagram size. So again, we should be able to test this pretty easily, right? We know. Excuse me. We know our sizes. So actually, let's say. Let's see how specific we can get here with our pings. All right, one, we want to do a DF bit. Well, it's probably. Yeah, do not fragment. Well, we can fragment. That's fine. And we will do the largest we can do 18. Let's do, what do we figure out on our numbers here? 3,200 bytes. And what is the rate it will send pings? Does anyone know the ping rate? I guess it just sends it out the interface as fast as it can. So let's do 3,500. And is that the datagram? That should be bytes. Interesting. All right, let's see what that looks like on router 4. Oh, we had a violate. Okay. We had 8 packets exceeded and 1 violated. That is fun, y'all. I'm starting to feel like Colonel Panic here. This could become a fun subject for me. So what we should see on our exceeded packets, yeah, it fragmented all right. It had to. It was larger than standard size. Here's our fragments. Okay, this is an IP. I want to see the DSCP is 0. Okay. So these were sent, but they exceeded the policy. So the precedence was changed to 0. And then what we should have actually is we should have a fragment that's missing. Sometimes you can see that in the wow, look how large these are. This is fun. So there you have it. So what I want to emulate now is, again, this is a large interface. It's a gigabit interface, but our policy, our CIR starts at 128 kilobits. So this is like, yeah, if you would have sent, back in the day, if you would have sent a big ping like this over a modem line, this is about, you know, or worse, what you would expect to see. More of these dots. What I want to try here, just for grins, and we'll probably have more opportunities to do this as we play with this QoS stuff more, is I want to adjust the quality. And what I'll do is I'll put 56. Well, with rate it should match. So we're going to apply that. And let's do it here. Both sides of the link, right? (128 kilobits per second). Okay, now let's just send some regular pings. But let's send a lot of them. Let's do repeat. Well, the thing is, I'm not sure what this quality is doing. I think it is. So this is interesting, right? This kind of illustrates what shaping would be like, because I think that is essentially what this is doing. It's shaping the interface so that it will not transmit at 1 gigabit per second. It will transmit at 128 kilobits per second. So what happens is you will never even exceed or violate the policy. I just figured that out, I think. I think that's what that is. Yeah, all the packets, yeah. Cool. So now we know what that does. All right, let's look at the final test here, and then we'll wrap it up for Thursday night. Let me look at the lab key. Oh, you know what I did wrong? This should be HTTP. Look at that. I forgot all about that. So what it would have been is my class map should have been just HTTP. Well, that would have been harder to, I guess, test. The main thing, though, is let's see if we got our police correct. And we did. So I did a class map to match all. It should have said match HTTP. And it would have been IP access list extended HTTP, right? Permit TCP any equals 80. Oh, sorry. I have to be very careful about that. In class map HTTP match access group name HTTP, and then we would have done our policy map policer class HTTP police 128.123.3200.40.0. Okay, well, we got that right. Thanks for the help with the chat. Perform. It looks like we could have done it in this format, though, which is fine. Either way works fine. I actually like this way better. Violate action drop. Okay, good. Whew. One lab down. Another lab down. Another lab bites the dust. That's going to wrap it up for tonight, folks. Got to get to bed early tomorrow. I've been to the gym 4 days this week so far, which is good. And tomorrow, hope to get my 5th day. And my body is been through a lot this week. A lot of pain, but in a good way. I'm paying for it. So we're going to wrap it up there. And the only meat chunk, again, this is a Kevin Wallace QoS explanation video. Thanks to Casadix, who made that available. Track that down. And what we will do is we will continue. I'm off Friday evenings from streaming, but I'll be back this weekend, and we'll hit, I think, our next lab, depending on what I get done tomorrow. We've got hierarchical policers and then a 2-rate 3-color policer. It's different on iOS and XE. I can imagine. Kernel panic. I can only imagine. And thanks so much for your help. Good night. Thanks for stopping in, everybody. You can follow me, of course, on Twitter, Instagram, YouTube. And, of course, you can follow me here on Twitch. And if you have an Amazon Twitch Prime account, subscription laying around, you can drop that here as well. Thanks so much for stopping in. We shall see you all this weekend. Have a great Friday. Enjoy your day, and see you then.